Good morning. I hope you had a good weekend. Here is the first set. We'll see how far we can get in the next 35 minutes of your practice final exam. So I will post these as soon as I'm done, and whatever I don't finish in this set will be posted later this afternoon as soon as I finish it. So our first question says, consider the equation 5x minus 3y equals 2. Does the point 3, 4 lie on this graph? So we need to determine if that point is on the graph. And the way that we do that is we plug, just remember that the 3 is my x value, the 4 is my y value, and I plug that in. So I'm going to have 5 times 3 minus 3 times 4 equals 2. And the way that we determine if that's on our graph is if the equation works out. So I have 15 minus 12, and that equals 2. And so then I end up with 3 equals 2, and that is incorrect. So that means no, that this point is not on our graph. Okay. Our next one, we're doing the same thing. We're just plugging 4 and 6. 4 is our x value. 6 is our y value. So I'm going to have 5 times 4 minus 3 times 6 equals 2. 5 times 4 is 20. 3 times 6 is 18. And that does equal. So this point 4, 6 is on the graph. That is on the graph of our line. Okay. Our second one says state the center and radius of the circle. The formula for your circle is x plus 7, the formula for a circle is x minus h squared plus y minus k squared equals r squared. Okay, hk is our center, and r is our radius. So we are going to look at this right here. Now look at the formula. The formula says minus h. So you actually want to think about this as x minus negative 7. And the reason that we do that is because the formula has the negative. So we have to break that down. We're kind of working backwards. Now this one already has the minus, so we're in good shape. And then we want to take the square root of 81 because our radius is squared. So the square root of 81, so I can rewrite 81 as 9 squared. So here, the 9 is my radius, the negative 7, and the positive 3 is my center. So the center of this particular circle is negative 7, positive 3, and my radius is positive 9. Okay, don't forget about this part right here. This negative is part of your formula for a circle, and don't forget in your formula for a circle that your radius is squared. For number 3, it says find the slope and the equation in slope-intercept form of the line containing these points. So what we are going to do first is we are going to have to find the slope. So the way that I find the slope is I subtract my y values, and then I subtract my x values. So I have negative 2 minus 4. That is going to give me negative 6. And then I have 3 minus negative 5. So that's going to become positive 8. I need to go ahead and simplify that. So my slope is negative 3/4. My slope is negative 3/4. So the second thing that I do is I'm going to put this in point slope form. So I'm eventually going to slope intercept, but I start here in point slope. So I have y minus y sub 1 equals m times x minus x sub 1. Okay? So I'm going to have my slope, and I'm going to use this point right here. So I have y minus negative 2 equals my slope, which is negative 3/4. And I'm going to multiply that times x minus 3. Okay? Y minus negative 2 is y plus 2 equals negative 3/4 x. And this is a negative 3/4 times a negative 3 over 1. So that is going to become positive 9 over 4. That's what happens right there, okay? So the negative 3 times negative 3 is positive 9. The 4 times the 1 is the 4. My next step is to minus 2 from both sides, and this is definitely some fractions that we're dealing with. Okay, so I've got 9 over 4 minus 2 over 1. Okay, so I need to change the minus 2 over 1 to something over 4. 1 goes into 4 4 times, so 4 times 2 is 8. So 9 over 4 minus 8 over 4 is going to give me positive 1/4. And I am going to rewrite that final answer just so you can see it. So my final answer is y equals negative 3/4 x plus 1/4. So be careful with those fractions. Make sure you're following all your fraction rules. And you want to leave that in fraction form. Okay? You don't want to turn that into a decimal. It's got to be fraction. Okay. Now we are graphing the line. And, well, it's going to be a little bit difficult to graph because we've got that fractional intercept right there. So we're going to do the best we can. Okay. So we are going to start at positive 1/4, which is going to be about right here. Okay. Then we're going to go down 3. So 1, 2, 3. So that's going to put us kind of down here. And then we're going to go over 4. So that's going to put us definitely off the graph. So your line is going to look something like this. And I did not do a fabulous job of graphing that just because of our scale. But that is pretty much what it's not going through the origin, but it's going close. It crosses the x-axis at 1/4. So that's what your line looks like. Okay. Number 5 says, give the equation in slope-intercept form of the line that passes through the point 7, 2 and is parallel to the line 3y minus 12x equals 2. So this is a point on our new line. Okay. The only thing that we need from our original line is the slope. That's the only thing that we need from our original line. So I'm going to take my original line and I'm going to find out my slope. So I've got 3y minus 12x equals 2. Okay. I am going to add the 12x to both sides. So I've got 3y equals 12x plus 2. Then I divide 3. So I have y equals 4x plus 2/3. Now, for something to be parallel, they are going to have the same slope. So these two lines are going to have the same slope. And the only thing that I need from my original line is that slope. This doesn't matter. So my y-intercept doesn't matter what it is on my original line. The only thing that I need is I need to know what my slope is. Now, if we were doing perpendicular lines, we aren't doing perpendicular lines, but if we were doing perpendicular lines, it's negative reciprocal, okay? So that means you take the 4, you make it the opposite sign. So instead of positive, it would be negative. And then instead of 4 over 1, it would be 1/4. Okay? And that is if you were dealing with perpendicular lines. We're dealing with parallel, but I just want to remind you the relationship with the slope there. Okay? So now we're going to deal with our new line. And so we are looking for a line that's parallel to y equals 4x plus 2/3 and goes through this point 7, 2. So we're going to use y minus y sub 1 equals m times x minus x sub 1. And I've got y minus 2 equals positive 4 x minus 7. Okay? Y minus 2 equals 4x minus 28. I add 2 to both sides. And my new line is y equals 4x minus 26. So what is happening here? This is the line. This is my answer right here. This line is parallel to this line. Okay? This is my answer, but it's parallel to our original line. And I just want to remind you, when you are doing these types of problems, you do not need to know the intercept on your original line. The intercept from your original line does not make any difference in your new line. The only thing that you need from your original line is your slope. Okay? Okay, number 6 says, give the slope of x equals 6 and y equals 10. Are these lines horizontal or vertical? So I'm going to go ahead and draw them just so that we can look at them. Okay, so I'm going to do x equals 6, and that is going to be a vertical line. Okay, y equals 10, it is going to be a horizontal line. Okay, so here is our y equals 6, or x equals 6, I'm sorry, x equals 6. Okay, so the red shows up. Our y equals 10 is going to look something like this, and that is a horizontal line. Here's your horizontal line. So x equals 6 is a vertical line, and our slope to the vertical line is undefined. Okay, so it's a vertical line. All vertical lines have an undefined slope. Y equals 10 is a horizontal line, and the slope of all horizontal lines is 0. So be sure that you know the difference in those two. The vertical lines are x equals, the horizontal lines are y equals. Vertical lines have an undefined slope. Horizontal lines have a slope of 0. Okay. Number 7. 7i says, if f of x equals x squared minus 2x plus 2, find f of negative 3, and find the domain of f of x in interval notation. So I'm going to start with the domain. What we look for the domain, when we have to limit the domain, you're looking for 2 things. The first thing that you're looking for is an x in the denominator. If an x is in the denominator of a fraction, your denominator can't equal 0. So if x is in the denominator, you would set denominator equal to 0. Okay? That is not the case here. We do not have a variable in the denominator equal to 0. Think about our vertical asymptotes when we're graphing rational functions. Now, the other time that we limit the denominator is if there's a variable in a square root or a radical sign. At that point, we set what is inside the radical Okay, you're not going to include the radical, but set what is inside radical as greater than or equal to 0. Because it's okay to get 0 inside the radical. What's not okay is to get a negative. You can't get a negative in there because then you're not dealing with real numbers anymore. So we don't have either one of those things going on with this particular problem. So we're talking about this problem again. Nothing. We don't have an x in the denominator, and so we don't have an x in a radical or square root. So our domain here is all real numbers. So that's negative infinity to positive infinity. Okay, so that's our domain. To find f of negative 3, all we do is we plug negative 3 in for all the x's. Now, when you've got negative 3 squared and you're plugging that in for x, you've got to square the negative also, and sometimes that confuses students, so be careful there. Okay, so negative 3 squared is going to be positive 9. Negative 6 times negative 3 is positive 18, and then we have plus 2. 9 plus 18 plus 2 is going to give me 29. Okay. Our next one does have a radical, and we do have a variable inside the square root. So in order for me to find the domain, I have to set what's inside the square root. It has to be greater than or equal to 0, okay? 0 is okay, and all positive numbers are okay. What is not okay are negative numbers. So we can have inside the square root, we can have 0 and all positive numbers. This is inside the square root. So we are going to set x minus 18 as greater than or equal to 0. Okay? So when I solve this, I end up with x is greater than or equal to 18. So what I plug in for x has to be greater than or equal to 18. Now I have to write that as in interval notation. So I'm going to have my brackets. I'm going to start at the number 18, and I'm going to go all the way to infinity. So that is my domain. Bracket at 18, all the way to infinity. To find f of 22, what I do is I set 22 in for x. So I am going to have the square root of 22 minus 18. 22 minus 18 is 4, so that's the square root of 4. And so my answer is 2. And remember, when you are taking the square root of a number, because the square root is part of your given problem, you only have the positive value. You don't have to worry about the negative value unless you're doing it like this. If you end up taking the square root of both sides, that's when you include the plus or minus. So in our problem, and this is not how our problem was written. The way our problem was written, we're only doing the positive. Okay. Next, we have a piecewise function. We're not finding the domain of our piecewise function. What we're finding is f of 2/3. So what we have to do when we find f of 2/3, we have to decide which rule we're going to follow. Are we going to follow the x is less than 4 rule, the s is equal to 4 rule, or the x is greater than 4 rule? And we are going to follow this rule because this is the rule we're going to follow, because 2/3 is less than 4. So I am going to find f of 2/3, and that means I am going to take 2/3 to the third power. Okay, and when I do that, I have 2 times 2 times 2 over 3 times 3 times 3. And that is my answer for that one. Number 8. Number 8 says find the zeros. And remember the zeros, we are looking at where the graph crosses the x-axis. Where the graph crosses the x-axis. Now, Don't make this harder than it is. This problem is already factored. You do not need to multiply this out. That's important because you're going to see some of those on your final where they are already factored. Your first step here is not to multiply this out. Do not multiply this out. Okay? If you do, it's going to give you headaches because all you're going to do is you're going to end up factoring it again. So for this particular problem, we do x equals 0, x plus 4 equals 0, and x minus 9 equals 0. Okay? So 0 is a solution, and it has a multiplicity of 1. Now look right here. We've got x plus 4 raised to the second power. Now this particular problem is not asking you for multiplicities, but if it was asking you for multiplicities, then negative 4 would have a multiplicity of 2. That means that that shows up twice. And remember, when it hits the x-axis, it bumps it and then it changes direction. So when I have an even multiplicity, that means it does not cross x-axis. Okay? That's what that means. And then our final one is x equals 9, and that has a multiplicity of 1. So we have 0, negative 4, and 9. And again, it's not asking for multiplicities, but I do want to talk a little bit about what that means. And again, our multiplicity of 2, it does not cross the x-axis. It touches it and changes directions. Okay? So if that was a parabola, then the vertex would be on the x-axis. This is not a parabola, but think about that's what this graph would look like if a parabola had its vertex on the x-axis. Okay? The next one says, find the zeros for 2x to the 4th minus 4x to the 3rd minus 70x squared. So what we have to do here is we have to take out anything that's common. We have to look for our greatest common factor. The good news is we do have a greatest common factor in here. We can take out a 2 and we can take out an x squared. And when I do that, I'm left with something much simpler to solve. Okay? So I've taken out the 2x squared. Now I can factor x squared minus 2x minus 35. So I'm looking for two numbers that equal negative 35 and two numbers that add together and give me negative 2. So those numbers are x minus 7 and x plus 5. Negative 7 times positive 5 gives me negative 35. Negative 7 plus 5 gives me negative 2. Now I'm going to set each factor equal to 0. Okay. Okay. So our first one, we have x squared equals 0 and x equals 0. Okay. So our first solution is 0. Now again, this has a multiplicity of 2. That means it shows up twice. And so it touches the x-axis and then changes direction. That's what happens at 0. Our next one is x equals 7. That has a multiplicity of 1. Our last one is x equals negative 5. And it also has a multiplicity of 1. Okay. Our next one, what kind of symmetry does y equals 6x squared have? So we can talk about multiplicity across the x-axis. We can talk about multiplicity across the y-axis. Okay. Or we can talk about multiplicity across the origin. Okay. So there's a couple of different ways that we can look at doing this. If you remember your even and your odd functions, they go very well with this, okay? Your odd function is only going to have odd exponents, and it's symmetrical across the origin. If something is symmetrical across the x-axis, it's not a function. Okay? And so in our situation right here, we've got y equals 6x squared. We know that's a function. If something is symmetrical across the y-axis, then it is an even function. And if it's an even function, it has to have an even exponent. I'm not saying that everything that has an even exponent is an even function. What I'm saying is that to be an even function, it has to have an even exponent. Now, to test to see if something is symmetrical across the x-axis, you are going to replace y with negative y. And you're going to see if they're equivalent. To see if something's symmetrical across the y-axis, you're going to replace x with negative x, and you're going to see if it's symmetrical. To determine if something is an odd function or symmetrical across the origin, you're going to do both. You're going to replace x with negative x and y with negative y. Okay? Now, because we have an even exponent, we really only need to test to see if it's an even function. And so we only need to replace x with negative x, and then we're in good shape. So I'm going to do y equals 6 times negative x squared. Okay? This means the negative is squared and the x is squared. So that makes it positive. So then we have 6 equals positive 1x squared. And that is going to be, so it is the same. So this is symmetrical across the y-axis only. It is not symmetrical across anything else. Okay? It is also considered an even function. It's an even function. Number 10. Number 10. So the directions on number 10 say to graph f of x equals x minus 2 to the third minus 5. What should we do to the graph of x to the third? So x to the third is our parent function. So remember, our parent function is x to the third. Okay, and when we have a value inside that is being raised to the third power, that is going to be opposite in value. So whatever's going on with our x is opposite in value. So if it says minus 2, that means we're moving plus 2. Now, if it's the y, that means it's going to go up and down, and it is true to value. Okay, so what is happening here is we are going 2 places to the right, and then we are going down 5 units. So what's happening here is we are moving the graph 2 spaces to the right, and down 5 spaces. And the down is because the negative and your y value is true to whatever it says. Okay, our next one is what is happening here. We've got f of x equals negative, and inside parentheses we have x plus 4 squared, and then we have our plus 3. Our parent function here is x squared. So anytime that we've got a negative outside of that, that means we're flipping the parabola. We're making the parabola go across the x-axis. Okay? So that's what's happening there. The 4 and the 3 are where we're moving things. That's where we're moving things. So our vertex is going to move negative 4 and up 3. So wherever our vertex ends up. So we have shift left, and we're going left because it's opposite in value. So that positive 4 means we're moving left 4. Okay? The 3 means we move up. That's what that means. Okay, so let's put all this together. We're going to shift to the left 4 spots. Okay, we are reflecting, because of this, we are reflecting across the x-axis. And then our last one is we move up 3 spots. Okay? So be sure you're kind of aware of what the negative means and that the x is opposite in value and the y is true to value. Now, I am going to stop right here. So we've gotten through numbers 1 through 10. I have to go to a class. I'm going to upload this. 11 through 22 you will get later this afternoon. Thanks.